Right, we'll look at distance time graphs today. So distance time graphs are plots of the distance an object has travelled against time. So there's a lot of things you can tell from these graphs, but they're used to just to describe an object's motion. Okay, these are motion graphs. Now, the first thing we'll talk about is what we can tell just by looking at the graphs, and then we'll start calculating some gradients as well, so that we can calculate the velocity or the speed that the object is moving at as well. So first things first, then we'll look at this graph here. Now, what's happening in this graph? So as time goes on, the distance that the object has travelled is increasing, because the line is going up in a straight line. Now it's increasing by the same amount each time. So if the distance that it's travelling is increasing, then that means it must be moving. And specifically it's moving at a constant velocity because it's not changing, it's not going up by more each time, so it's moving at a constant speed here. So what about this one then? Now we know that it's a straight line still and it's going up, so it must be a constant speed again. But how does this constant speed differ from this constant speed? So if the distance is increasing, it's just not increasing by as much. Therefore, it must be a slower constant speed. So already we've learned that the steeper the line, the faster the object is moving. Okay. Now, what about this one here? So as time goes on, the distance that it's moved is not changing. So the distance the object has moved is not changing at all. Therefore, it must be moving at, well, it's stationary. It's not moving at all. Distance isn't going up. It's not changing, it's not going any further, so it's stationary. Okay, right, let's have a look at these two. Right, these two are a little bit more complicated. So what's happening let's start with this one here. So what's happening here? As time goes on, distance is going up, so it is definitely moving, but distance is going up by more as time goes on. Okay, so it's actually, the gradient of the graph is actually increasing, the steepness of the graph is increasing. Therefore it's accelerating, so this is actually getting faster. Okay, and then this one here, it starts off really steep, but then it gets really shallow, so the velocity is going down, it's deaccelerating. Okay, right, let's have a look then at a graph. Well, let's just go over these. So we've got constant speed if it's a straight line going up, and then a slower constant speed if it's less steep or the gradient is lower. If it's flat, it's stationary, and if it's curving down back flat again like this, then it's decelerating. If it's going up, curving upwards, then it's accelerating. Right, so I've plotted a proper distance time graph here for an object. Okay, so let's have a look at these sections. We know in this first section, let's call this section A. In section A, it's moving at a constant speed. Okay, so the object is moving, and then in section B, it stops for a bit. In section C, it moves a bit slower than it did in section A, and in section D, it suddenly starts moving very, very quickly. Okay. Now, how do we work out how quickly it is moving? Now, you know that speed is equal to distance divided by time. Okay. So that's what we're going to use in this video. We're going to use distance divided by time. Now, first bit of the graph, distance is on the y-axis. So how far has it travelled in section A? It's travelled a total of 8 meters in section A, and it's also done that in 4 seconds. So the distance of 8 meters. So to get this, you take the distance of 8 meters. Let me just change my pen color. So we take 8 meters and we divide it by 4 seconds, and we get a velocity of 2 meters per second. Okay. This section B, clearly it's not moving, it's stationary, so this is 0 meters per second. So let's look at section C as well then. Okay, so at section C, it starts at 8 meters, okay, and then how far has it moved from there? So it's moved to 16 meters, okay, so it starts at 8 and it moves to 16, it's moved a total of 8 meters, okay. How long has it taken to move 8 meters? Well, it started at 8 seconds and it went up to 16 seconds. Yeah, so 8 seconds to 16 seconds, that's 8 seconds. So 8 divided by 8 is 1 meter per second of velocity. Okay, now if you want to have a go at section D, do that really quickly now. Pause the video and I will run through it when you press that unpause button. Okay, let's run through it. So section D then. So where does it start? It starts at 16 meters, okay, and it goes all the way up to 26. 16 to 26, it's traveled 10 meters, yeah? How long has that taken? Well, it started moving at it started this in section D at 16 seconds, okay, and it's taken 2 seconds to get to 26 meters per second. So it's 16 to 18, it's gone up by 2, so it's 10 divided by 2. You get a gradient of 5 meters per second. Okay, so clearly this is the fastest one, which makes sense because it's steepest. Yeah. Right. Next video we'll look at velocity time graphs, and I'll see you then.